25. This table, 928, provides suspended solids concentration in several different waste streams at the municipal wastewater treatment plant. The BOD5 is measured in the sewer located just before the treatment plant. Okay, so just before the treatment plant is 250 milligram per liter. This is the BOD5 before entering the treatment plant. After primary treatment, it was 150, so there was a reduction. So initially, from the sewer, entering the primary tank, it was 250 milligram per liter. This is BOD5. Entering the primary tank, and then leaving the primary tank. Oops, let's see. It is 150 BOD5, 150 milligram per liter. Okay, and after secondary treatment, so this is going to go to aeration tank, and then secondary clarifier, okay, and then the recycled back waste and some wasted sludge. So after the secondary treatment is 15 milligram per liter. So BOD5 leaving the secondary clarifier is 15 milligram per liter. The total nitrogen levels in the plant are approximately 30 milligram nitrogen liter. Now, this suspended salt concentration in the plant effluent was 200. In the primary sludge here, it is 5,000. In the secondary sludge, it's 15,000. So in the secondary sludge here, it's 15,000. In the aeration basin effluent here, or inside whether it's leaving the aeration basin or inside, should be the same. So here, it's 3,000 suspended solid. This means this is how much is microbial content of the aeration basin. If the design hydraulic retention time of each 4 aeration basins operated in parallel equal to 6 hours, so he gives you the hydraulic retention time. Okay, so HDT is 6 hours. Okay. Now what else is given? For 6 hours, and total plant flow 5 million gallons per day. What is the F over M ratio? What is the F over M ratio in units of bound, BOD5 bound mLVSS per day? So let's find out F over M. Let's put the equation F over M. F over M, food over microorganism ratio, Q naught, S naught, Vx. Now, remember here in the FM, he made it as mLVSS. mLVSS. While here, he gave it as MLSS, or suspended solid. So this cannot be done like this. You have to make an estimate, because an estimate of 0.6 to 0.8 of the MLSS is organic, MLVSS. Okay, so 0.6, 60% to 80%. Sometimes they take a 70%. Sometimes they get 80%. On average, they take a 70%. But for the purpose of this book, we'll take 0.6%. So, using the 0.6%, and the MLSS inside the aeration tank was 3,000, because it's mentioned here 3,000, and that is the suspended solids concentration of the aeration tank. This would give you 1800 milligram VSS, volatilized suspended solid per liter. So now, let's find out. Now we know the equation. What's needed here? What is what is the F over M ratio? Okay. So F over M is equal, what's Q naught? Remember, remember it was given, it's 5 million gallon per day. 5 million is 10 to the 6 gallon per day. What is S naught? S naught, it was the BOD entering 150 milligram per liter. Okay, divided by the volume. What was the volume? Well, here there is the volume was not given, but what's given was volume over Q, 6 hours. Okay, so if you want to find the volume, you could make it like this: 6 hours is equal volume over Q. What was Q? The Q was 5 10 to the 6 gallon per day. Now we have to convert day to hours in order to cancel out hours with hours. Okay? And you could make the volume in gallons. Okay, so 6 hours, let's just change 6 hours. 6 hours day, 1 day is 24 hours. Now this is like this, and volume is equal 5 10 to the 6 gallon per day. Now day with day. So you'll end up with volume in gallons. What is wrong with the screen? So let's do this. So 6 over 24, and that is 0.25 times 5, that is 1.25 10 to the 6 gallon. That's the volume. So we will put the volume here. Oops, what is wrong with the screen? 1.25 10 to the 6 gallon. So now it's good. Gallon will go with gallon. Nice. So we do this. What else? What's needed here now? We need to find out what is X. This is the volume. What is X? X was the actual concentration of the biomass inside. We have it here. 1,800 milligram. Now this is milligram VSS per liter, and this is milligram BOD 5 per liter. Okay, and this is it. 5 10 to the 6 gallon, cancel with gallon, and 150 milligram per liter over 1800, 1.2526. Let's look at the calculation. So let's see, 10 to the 6 with 10 to the 6. So it's 5 times 150 over 1.25 over 1,800. And that is, oops, 0.33. And let's clean up this. Okay, so now we have the F over M. Okay, this is gonna be, you can see it. It's milligram BOD5 over milligram MLVSS, of course, and the day is here per day. Of course, liter with liter is gone. Milligram per milligram is equivalent to bound BOD5, because that's what we want the units, over bound MLVSS day, or kilogram over kilogram. It will cancel out. Okay, so that's the F over M. Now let's look at B. Suppose that plant engineer wishes to increase the concentration. Now he wants to increase the concentration of the microorganisms in the biological reactor. So we need to increase this, okay? Because she expects the substrate level to increase. She thinks that this BOD, she thinks this BOD coming up to the plant will increase. She wants to increase the bacteria or the microbes to equate the food coming to the system. Okay? What would she command the operator to do to accomplish this goal? Okay, so now what to do? Okay, so in order to increase the mixed liquid suspended solid 3000 milligram per liter in the aeration tank, you have to reduce the amount of solids that are wasted. So whatever wasted here, we need to reduce this amount and increase the recycled activated sludge. Okay, which means if you reduce wasted and increase the recycled, which means that you are increasing the solid retention time. Okay, so you should tell him increase SRT, or you should tell him don't waste much, or you should tell him increase the recycling of activated sludge system, activated sludge.